Welcome to today's webinar. The topic today is features introduced, cloud calculation, blocks and more. My name is Andreas Hörold. I'm responsible for marketing and PR in the company Dlubal Software. For instance, the technical content of the website, German and English webinars, newsletters, and so on. I will be the moderator today and also the presenter. My colleague Marco Nikolajczyk will support me. He will answer your questions during the webinar. Marco is responsible for customer support in our company. He answers the questions for our customers. Okay, then I say something how you can ask questions, at least for the attendees who participate the first time. At first, I switch off my camera that you can see the full screen. Just press that button with the question mark, then enter your question here, press send, and Marco will receive your question and he will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. To the agenda today, the first point is cloud calculation. I describe or explain the workflow. Then I show the blocks and import the block. Later I will show the optimization of cross-sections, steel cross-sections in our case. And the workflow is also valid for other materials such as timber, aluminum, and so on. Then I add parameters to the model. I save the model as template and open the template again. Then I explain the object selections and parts list. So we turn to the first point, cloud calculation. What are the advantages? The most important advantage in my eyes is that your own computer is not burdened by the calculation. And also that is important when you send the calculation to the cloud and you leave the program, any other colleague, for example, can use your license. You don't block the license. It's useful if your own computer is not powerful or for large models. You can choose between different servers. I will show that later. You can do variance studies. Also, our wind calculations are possible. And you can see the calculations in the extranet or the calculation shops. I will show that as well. And the calculated files are available for download for 30 years. That's the workflow. I will show the workflow directly in the program. If you want to do that later and you want to see that slide here, just download that slide from our website. In the next days, you will get an email with your attendee certificate with a link to the website with the recording, PowerPoint slides, and the provided model. Okay, then we turn to the program. That's a model from a former webinar with 16 steel joints. And the calculation would take some time. It doesn't contain any results at the moment. That's why we would like to send it to the cloud or calculate it in the cloud. You can reach the cloud with that button, calculate in the cloud, or you can find it under calculate in cloud. So the first step it would be you have to buy credits for cloud calculation. I press that link, then we turn to our website. So, and you have to select more from this category, and you see the credits, and you can buy the credits. Yeah, and if you buy 1,000 credits, it would be, costs 100 euro, and 5,000 credits, 400 euro. In that case, one credit would cost 10 cents. Okay, we turn back to RFM. Then you need to select the virtual machine where are Dlubal servers. With that servers, you can also do our wind calculations, and those are the Microsoft Azure servers. You can do a plausibility check before the calculation or before sending the file in the cloud. Yeah, and you can also send, or let's send notifications at the start and of the completion of the cloud calculation. Yeah, I would recommend at least to select that button, that you will be informed immediately after the cloud calculation is done. Okay, then we would start the calculation with a press of that button. I did that already last week. That's why we turn directly to calculate external calculation tasks. I also got an email with a link, but you can also find the link here, API and cloud, and you can see that's the file, carport. It was calculated successfully. That would be the price. So then I downloaded the file with that link. That's the same link as in the email. So, and now I search it in my Explorer. So just a moment. At first I turn back to RFM. So, and now I open the file, the calculated file. That's more than 3 gigabyte large. That's why it takes some seconds until it will be opened. We wait some time. If the file is larger, then it could be that you get a zip file, and then you have to unpack it before opening. So now we have got results here for all nodes and all joins. Okay, that should be all to the cloud calculation. I close the files. So, and we start with a new file, and with that file I show the other features as blocks, optimization, parameterization, templates, and so on. So left above, new model. I will show all on a truss, and I would like to do a steel design. That's important to select it, otherwise I couldn't show the optimization. I select the European standards and the German national annexes. Okay. And we use also member representatives. So that's the empty model. And now I turn to the blocks. You can see that left above, block manager. And you can see all the parameterized blocks, single span beams, continuous beams, columns, arched beams, trusses, 2D, 3D frames, and so on. Maybe show some other things, surfaces. What is also important, maybe bridges. Yeah, just take a look at the blocks, what is useful for you. I will show that on a simple example on a 2D truss. I select this one. Okay, those are the dialogues of the block. Main, structure, categorization, JavaScript. On the main dialog, you can, for example, select the position of insert point. That's okay in our case. I think the most important dialog is the structure. You can modify the parameters. And in this dialog, you could change the JavaScript code. You could add more parameters. Just uncheck that button below. And now you could modify the code. I will show how you can add parameters without programming knowledge, but later. Okay, then number of base, that's okay, 6. Then input via L and L1. I enter the total length, 18 meters in our case. Then the length of the outer base should be 3 meters. And the length of the inner base is calculated automatically. The height is okay. I switch the view. So, and I modify the top chord. It should be an HEA 200. Okay, the material is okay, as 335. Okay. The bottom chord should be also another cross section. I change it to HEA 180. This one, okay. And for the diagonals and verticals, we create a new section, an HEA 100. 120, sorry. Okay. So the model, or the block is finished. We can press OK. So, and this is our model. The member representatives are created automatically. All objects with the same properties or with the same length and the same cross section are collected in one member representative. And we have to select or modify or enter the design properties only for one member representative. But we will do that later. So at first we explode the block with right click on blocks. And now we lost all the parameters. But as I said, I will create the parameters later with another method, sorry, and without programming language knowledge. So I modify the supports. This one should be movable in X direction. So this one, okay. So I also modified this one. Okay, around the longitudinal axis. Okay, and we have to support truss in Y direction or the upper chord. So left above, new nodal support in Y direction. Okay. The model is completed now. We create a member set for the lower chord members. Create member set, because later we will check if the deformation for the 18 meters is low enough. So, okay. So the next step are the loads. We enter the load case self-weight, some forces, 9 kilonewton in Z direction. Okay. That nodes. Can decrease it a little bit. Okay. Yeah, and we assume there are neighbor trusses. That's why the value at the edge is the same on the inner nodes. Okay, so then we turn to the dialog load cases and combinations. And we create a new load case. Yeah, those are the base data that we entered at the beginning. Load cases. Now we copied that load case. We deactivate the self-weight. Then it should be snow. And we call it snow. Okay. And we have to modify the load. 15 kilonewton. Yeah, we have got only 2 load cases in that example. That is enough. So in the next step, we create imperfections. But before we do that, we calculate that load case, that we can see where is tension and where is pressure. The pressure should be on the upper chord and on the vertical beams. So members, internal forces N, okay. Now you can see where are pressure, well, there's pressure on the upper chord and the verticals. Okay, that's why we create design settings where we would check the buckling for that members with pressure. Okay, and in the first step, we enter imperfections. New member imperfection above. I call it imp. Okay. We create initial bow according to Eurocode 3 in direction of the weak axis. Okay, and we apply it for the upper chord and the verticals. So that looks almost good, but I changed the direction for these 3 imperfections. Double click, -y. Okay. Yeah, that curves are looking quite better. So then the next step is we have to select the design settings. At first for this member representative. I enter a new effective length. That is what we determine, the flexible buckling, torsional buckling, and lateral torsional buckling. So the supports at the beginning and the end are created automatically. And we enter the effective length factor 1. We assigned imperfections. We calculate according to the second order theory. And those are the with these settings we can design according to Eurocode 3. Okay. And for the upper chord the same. For the member representative, design types standard. With the buckling length factor 1. And if you want to design according to the general method, you have to enter boundary conditions. We use the equivalent member method according to Eurocode 3. Okay. So that's all for the ultimate limit state design. For the serviceability limit state design, we have to create settings for the member set. So I select design properties. And you can see where are the 18 meters. That's important for the deformation design or the ultimate limit state design. So we can start the steel design now. Okay. I forgot something. Yeah, you can see the design ratios, but I have to turn back again to the load case and combinations. The design situations. Yeah, we want to design only this design situation for the ultimate limit state and only the design situation for the serviceability limit state characteristic we want to use, and for the geometrical linear method. So, and we can delete these two design situations. So in the overview, we have to create the load combinations. And you can also see the imperfections are assigned to the combinations for the ultimate limit state design. And when I turn back to the design situations, you can see the assigned combinations. So that's okay. And now we can calculate all again. Now we will get the right results. Okay, design ratios on members. I select design ratios or by section. Yeah, you can see there are quite low design check ratios. And in the next step, we would like to optimize these cross sections. At first, I would like to go to switch to design ratios by member set. And you can see the serviceability design, deflection and set direction. When I double click on that formula, now you can see the design check is for 18 meters. That's okay. So, as I said, we optimize the cross sections in the next step. I turn back to input data, then sections. You can see the design ratios, and we select optimize current row for all. And we do the steel design again. So, and now you can see the higher maximum design ratios. But the section for the global model isn't changed. We have to do that in the next step. Use all optimized sections in model that we consider in the global calculation the right stiffnesses of the sections. So we calculate again. So and now we got the right design ratios. Okay, then that should be all to the optimization. New, we turn to the parameterization. So I would like to parameterize loads, or this load, only the self-weight load, then the height and the length. So at first we have to turn back to the structure on the table, and you can find the global parameters here. At first we enter the height. The current height is 2 meters. Then the length. Current length is 18 meters. Then self-weight roof. The unit group isn't the lengths. And now you can see what parameters you can define. Materials, section parameters, model parameters, and load parameters. So we select force per uniqueness force. We select surface loads. So, and 0.5 kilonewton per square meter is the current self-weight of the roof. And we enter the spacing of the trusses. And the space of the trusses at the moment is 6 meters. Okay, that's all. And we can start with the parameterization. So in the first step, we select all these nodes on the upper chord. Then with a right click, I go to Nodes, Edit. So, and when you press on that button, you can edit or enter a formula. I click on that button, Edit Global Parameters. I double click on the height, or I press OK and Insert. And we have to enter minus height because the direction of the Z-axis is in direction, it's in direction downwards. Okay, So, and the next step, I select these nodes, right click, nodes, edit. This is similar workflow. I double click on the length, 80 meters. Okay. So, and we have to do that for the other nodes as well, but with another formula, nodes, edit formula, length, multiplied by 5 divided by 6. Okay. So then these nodes, edit, so length, multiplied by 4 divided by 6. I can copy that with Control C. Okay. So then these nodes, edit formula, Control V, and I enter 3 here, or half would be possible, 3 by 6. Okay. Okay, now the last one, or the last step. Okay. So those are these parameters. So and now we parameterize the load only for the self-weight load case. That's the same workflow, or it would be the same workflow for the snow load case. So double click on that load. Then I edit the formula. Then self-weight of the roof multiplied by the spacing multiplied by the length and divided by 6. Okay, and we've got 9 kilonewton. Okay, all parameters are set, and now we turn back to that dialog. I increase the dialog a little bit. So, and now we can change the values. For example, 1.5, 20 meters, 1 kilonewton, another spacing, and with apply, all is changed. That would 20 meters, 1, 4, apply. Yes. Okay, those are the new distances and loads, and you can modify all what you want, or you can modify only these parameters. So I change it back again. So that's the original truss. And if you don't want to lose the design properties, parameterization, and so on, then we go to File, then save, or we can save it in the first step. Save. And then save as template. In the first step, we have to enter a template category name. I call it parallel trusses. Create a new folder. Yeah, and you can also use another folder, for example, on a server that also your colleagues can use the parameterized template. Okay, and I call it truss style 6 fields. Okay. So now we can close that model, and when we go in the Dlubal Center, so now we can see the model templates here. We have got only one template. I double click on it. And you will see the parameters are still where. I call it T1. Okay. Yeah, and the parameters are still there. So let's change only one parameter, the length, 21 meters. Okay, and now let's check if the style design is still okay. Okay, this is not the case. The design ratio is higher than 1. Yeah, the next step would be changing the cross-section, or we could do an optimization for the cross-section of the upper chord. But we don't do that in that case. Okay, then we turn to the next feature, object selection. In FM5, it was on another place. In FM6, you can find it under guidelines, guide objects in the navigator data, and then object selection. Now with a right click, you can create a new object selection for nodes, members. Can you use for the basic objects, then types for nodes, and so on. I showed it on example for members. Definition member section equals this one, and I call it upper chord. Then we create a new selection, also members section. This one, lower chord. So then a new one, members section, this one. But yeah, we don't want to select the verticals and the diagonals, in that case only the verticals. That's why I select and the section and parallel to member, this one. Okay, and now only can press apply, or we can leave the dialog. You can see only the verticals are selected. We create a last object selection new object selection for the diagonals. Members, section, the section, and this length, if all lengths are equal for the diagonals. If not, you can also select parallel to member, this member, and I select here or parallel to this member. Okay, that's all. Now we turn here left at the bottom to views and we activate the object selection. Now all is selected. So now only the upper chord. There's something wrong. Lower chord is okay. Verticals, I can rename it. Verticals. Okay. Diagonals isn't okay as well. What is wrong? Section equals this one. The rest is okay. Now it is okay for the diagonals. What is wrong for the upper chord? Edit equals this one. And parallel to member this one. Okay, now it's okay. Good. Then we turn to the last feature, the parts lists. How can you create parts list? In the printout report, at first I have to calculate all. I only calculated the self-weight load case. Calculate all. So left at the bottom, we turn to the navigator data. We create a new printout report. I select all and deselect all. And I create only a parts list. For example, members by material, total values, and parts lists all by material. Press save and show. And the printout report will be created only with the parts list. I move it from the other screen to this screen. You can see the different cross sections, the length, total surface area, and so on. And the total mass, for example. Okay. That should be all for this webinar. I hope you liked some features and you learned a little bit. Okay, then I turn to the PowerPoint slides because I have an additional hint. You can book our online courses. Just press the button on the at the bottom for the single courses. FM Masterclass course. It's a course for beginners. Then Eurocode 2 course. Eurocode free course. You can also scan the QR codes to get more information and the price. Yeah, that's quite easy. Okay, that should be all for today's webinar. Thank you for your attention. Thanks to Marco for answering the questions. I wish all a nice rest of the day. Bye-bye.